What is a digital coherent optic and how it can be used in the ASR 9000 routers, especially in the latest 5th generation products? Today, in this video, we will talk about ZR Plus Optic, which is supported on 5th generation line cards and new compact routers. We will clarify all possible confusion about supported DCO optic, use cases and configuration options. My name is Alexey Babaytsev. I am a technical marketing engineer in Cisco MIG H team. So, what is a digital coherent optic? For better understanding, let's take a step back and remember that in traditional DWDM systems we use a very important element as a transponder. With transponder, we take the incoming client signal, usually it's a gray signal from the router or switch, and convert it into the ITU-tuned wavelength. A regular transponder card has a number of discrete components, the modulator, the digital signal processor, and other components. But the size of the transponder card and power consumption are not optimal. The idea of digital coherent optic is to take all the discrete components and package them very efficiently using different technologies like silicon photonics integration and advanced packaging integration into the smaller, pluggable form factor. Also, we can leverage digital signal processors moving to 7nm technology. Because it's a pluggable module, we have to choose the appropriate form factor. There are several form factors which could be used for DCO modules: CFP2, OSFP and QSFP-DD. And it was the QSFP-DD form factor that Cisco chose to combine all the discrete components to make 400 gigabit DCO. The benefit of QSFP-DD DCO is a massive improvement from the power consumption perspective and from the port density perspective. Now, if we have a router or switch, we can use ports on the line cards, either with gray optic or with a coherent optic. We don't need anymore to use special dedicated IP over DWDM line cards or transponders to get a digital coherent signal. If we take a look at the modern digital coherent optic solutions, there are several options. The first option is 400 gigabit ZR, which was standardized by Optical Internetworking Forum, OIF. This optic can leverage 400 gigabit client signal on the input, and on the output side we have 400 gigabit ZR ITU-tuned wavelength. This option uses CFAC concatenated forward error correction method, and it's optimized mainly for metro deployments. It can support up to 120 kilometers. In parallel, another organization, the OpenRODM group, developed another standard targeted at the wider spectrum of use cases: metro, regional networks, and long-haul solutions. This option allows to use almost any clients: 100 gigabit, 200 gigabit, 300 gigabit, and so on. On the line side, variety of line rates are available, and this ability to work with RODM-based infrastructure. High-performance FAC, OpenFAC, is used here, and it allows to support a much better OSNR ratio, and you can go much longer distances. So, based on these two standards, 400 ZR and OpenRODM, the third variant was built, OpenZR Plus. It's Ethernet-based, and it can support 100 gigabit Ethernet, 200 gigabit Ethernet, and 400 gigabit Ethernet clients. On the line side, it allows to get 100 gigabit, 200 gigabit, 300 gigabit, and 400 gigabit. Important thing here that high-performance FAC was adopted for this option as well. With OpenZR Plus, you are able to go much further distances with respect to data rate and fiber quality. If we are talking about a ASR 9000 platform, today two options are compatible with 5th generation line cards: OIF 400 ZR and OpenZR Plus. Both options use the QSFP-DD form factor, and they are available starting from the 7.3.2 iOS XR release. Now, let's talk about features and configuration options which are supported on ASR 9000. When we have ZR and ZR Plus Optic, two main modes can be used. muxponder and transponder. Both modes have the same meaning as we had in traditional DWDM systems. When we use transponder mode, the client signal is converted to the DWDM channel or lambda, and then the channel is carried over the optical infrastructure. The muxponder mode means that we can have several client signals, multiplex them to one DWDM channel, and then, on another side, demultiplexer is used to get original client signals. When we talk about ZR and ZR Plus optic, important to mention that only point-to-point topology is supported. It means we cannot take several client signals and distribute them between different remote locations using several lambdas. One DWDM channel or single lambda is used to carry client signals. Transponder mode can support either 400 gigabit client or 100 gigabit client. Muxponder mode can combine 2, 3 or 4 100 gigabit clients. And of course, both sides should be configured in the same manner, either transponder or muxponder. Now let me explain which interconnect options and topologies are available when we use ZR or ZR Plus optic with ASR 9000. The first example is a symmetric interconnect solution. Symmetric means that we have the same router configurations on both sides. For instance, when we use transponder mode, we can carry either a 400 gigabit client signal or a 100 gigabit signal over the DWDM channel. ZR Plus optic supports both rates, while ZR can be configured only with 400 gigabit rate. In this solution, both sides support the same rate, and ZR Plus optic is part of the router. Between routers, we can have either a Cisco DWDM system or it can be a third-party solution. In the case of the muxponder mode, we can have a set of different options. Muxponder mode allows carrying several low-rate client signals over the one single lambda. ZR Optic also supports muxponder mode, but only 4 by 100 gigabit configuration is supported. ZR Plus can provide multiplexing of 2 and 4 100 gigabit rates. This is also a symmetric solution, because we have the same router configurations on both sides. Besides symmetric topology, DCO-based solution can be built in an asymmetric manner. When this option can be useful? For example, you are migrating your infrastructure to a pluggable DCO solution, and you have an upgraded central site and a number of legacy sites that don't support DCO optic yet. In this case, the central router site is configured as a 4 by 100 gigabit muxponder mode, and DCO pluggable module will transport those 100 gigabit streams using a single wavelength at 400 gigabit rate. On the remote location, the muxponder will break out 4 individual 100 gigabit interfaces to non-DCO routers using gray optics. You can use Cisco NCS 1000 or NCS 2000 with muxponder card to build this solution. Another option is to use a pluggable 400 gigabit DCO optic together with ASR 9000 on one side, but on the remote side we can have a 400 gigabit solution based on a standalone transponder with ZR Plus support and a router with a gray 400 gigabit optic. This use case can be an option for customers who migrate their legacy optical architecture to the innovative routed optical networking solution, because it allows integrating their non-DCO routers to the new DCO-based infrastructure. Which exact options are available today for 5th generation products? We have 3 line cards that can support DCO optic, specifically 2T, 4T and 800G line cards. All of them support both ZR and ZR Plus optics in the transponder and muxponder modes. 2 flexible combo cards, 2T and 800G, defaulted to 100 gigabit on QSFP-DD ports. This means that you will need to configure the breakout option at the NPU level in order to put the ports in 400 gigabit mode. And vice versa. On the 40 line card, all QSFP-DD ports are 400 gigabit by default. 2 new compact routers, ASR 9002 and ASR 9003, both support DCO optic as well. 9003 has a 2T port expansion card that is capable to plug ZR and ZR Plus modules. 9902 is also DCO capable, but because it doesn't have any 400 gigabit ports and only 100 gigabit ports are available, you can plug ZR Plus Optic and QCPDD ports, but in 100 gigabit mode only. Now let's talk about the configuration options of ZR Plus on ASR 9000. Compared with the regular grey optics, which usually require a configuration on the NPU level only, DCO optics also need additional tuning on the DWDM level. For example, you can configure a wavelength, FAC, rate, optical transmit power and other parameters. Depending on the mode, some parameters can be left without change. There are default configurations, but other parameters can be tuned accordingly. On the NPU level, usually we need to choose a breakout option only. But depending on the line card you use and the DCO mode you are planning to enable, the breakout configuration might be not required because the port can be in demanded mode by default. There is a difference in the configuration of the breakout option for regular line cards and for the ASR 9903 port expansion card. You have to use the bay keyword to point at the sub-slot for the port expansion card. The third level, where some configuration might be required, is the coherent DSP controller level. On this level, you can configure optional parameters, like performance monitoring parameters and some other options, for example, internal or line loopback. So, it wasn't a long video, but we considered several very important topics which can be useful for the understanding of new DCO pluggable optics as a part of ASR 9000 routers and the Cisco routed optical networking solution. In future videos we will talk more about ASR 9000 and the latest 5th generation product line. We will touch on different aspects of functionality, hardware and software design. Thanks for watching, guys! If you need any more information, click on the links below. Stay with our channel. Don't forget to like and subscribe. And we will see you next time.